So let's start with Typhoon HIL Control Center. So just briefly introduction to our toolchain. So here, I hope you can see my screen well. So this is Schematic editor. It's actually a place where you can build your models, define your functions, and also where you introduce your inputs from external devices. Then we have HIL SCADA, where we actually run our models and observe some signals. Also, it's the place where we actually set our outputs from HIL device. There is also Typhoon Test IDE. It's actually an environment where you can create your automation tests. Okay, so first thing, let me introduce you our schematic editor. On our left side, you can see we have some libraries, such as communication library, machine libraries, and so on. Also, this is actually our model. So I'm going to skip jump actually from model to camera. I hope you can see the testbed. So first thing that it's up here, it's actually HIL 604. I hope you can see it not so well, but yeah. So we have here 3 HILs. We have here active filter, 2 of them. So I will jump back to control center just to show you the implementation of this component. So this is actually the control part. So the power stage is actually here. So let me jump inside. So this is actually, let's say, one of 2 active filters. So it's actually T-type 3-phase inverter with some LCL filter, and we have 2 of them. So let me jump back to camera. So as you can see, we have 2 screens. So each of screen controls one of our active filters. Okay. So the next thing that I'm going to explain you is Woodward controller. It's actually a very popular type of diesel controllers. So let me just jump back to our screen. So as you can see, we have 3 of diesel generators here. One, it's actually using this controller, and 2 of them are actually virtual one. So we managed to create internal control, and then it behaves pretty similar like any other diesel generator. So this is also important thing to mention, that we have our microgrid library where we actually have some of these. So we have also pre-packed diesel generator. Also we have pre-packed battery inverters and so on. So here, let me just try to explain you how this looks from model point of view. So as you can see, we have here some digital outputs. So how we defined inputs, sorry. So we just define the number of input that is actually connected to device. And also important thing here is that we have speed base and voltage base. Actually, these signals are actually coming from the real controller. So we are going to use these 2 signals for controlling our diesel generator. Okay, so next thing that I'm going to show you here, it's actually a cell relay 751. So here, let me just jump back. So as you can see on our left side, so we have also some digital inputs to our system. So these inputs they are actually coming from the relay. And how it works, it's actually monitoring these values here of voltage and current. In this case, we will show you the instantaneous overcurrent operation, and then we control this conductor. So also we can use this fault. So it's actually phase-to-phase fault. And also important thing to mention is that how these thrusters are implemented. As you can see, it's simple three-phase diode rectifier with some capacitor and variable resistor also. Okay. So this is, let's say, simple model of thruster. What else we do have here? Let me jump on camera. Okay, so here we have another HIL device, and then we have this gray box, which is actually our HIL Connect. So we can imagine this as amplifier. So signals that coming from HIL device is actually plus minus 10 volts, and using this gray box, which is actually HIL Connect, how we call it, we can amplify it from, let's say, hundreds of 100 of volts and plus minus and so on. And also with current, same thing. And also we have here another device, HIL, and then we have two boards of battery inverters. So in this case, we are going to only to use one, and we are using CAN communication protocol. Okay. So now we can jump on simulation part of this. So yeah, let me just show you briefly where we have this. So as you can see, this is battery inverter. So from EPC, and let me just, oh yeah, sorry. Yeah. So let me just show you again. So this is actually our battery inverter. As you can see, we have on DC side, we have pre-charge circuit. We have three-phase inverter. Also, this is pretty easy how we actually connect the external device with our HIL. So it's actually, we just define some digital inputs, and these names we can find in help. So you can see the familiar structure of three-phase inverter. Okay. So also we have some measurements and so on. Yeah, more or less that's it from all components that we are going to use here. Also, there is some loads, there is some transformers. This is some constant load and so on. So this is actually our HIL SCADA. On our left side, you can see some widgets that is going to help us to monitor some values. Also, there is possibility to use data loggers, frequency response, serial connection, and so on. So on our right side, it is important to mention that we have some model settings. It's actually place where we can control all the things that we put in our model, such as contactors, switch, sources, machines, and so on. Also, this is place where we actually defined our outputs from model. So in this case, we would define some voltage measurement that our controllers are going to regulate, or some currents, and so on. And this is actually our SCADA panel that I'm going to show you. So let me just briefly jump on it. So this is actually our special widget, which is capture and scope. It's actually a place where you can monitor all the data in real time. So first thing that I'm going to show you is one simple test. This is actually our SCADA, and you can see how it looks like. So first thing that I'm going to show you is turn on this diesel generator. So as you can see, this is special widget for it, so we can find all monitorings that we are looking for. So let me just briefly. Okay, so I hope you can see our diesel generator. So now I'm going to use one button from it. So it's auto, so it means that it will auto start the diesel generator. So as you can see, I'm not doing anything with model. I'm dealing with real controller. So let's start it. Okay, so now it's ramping up. So also you can see here the behaviors, and I hope now it will start the synchronization process. Yeah, as you can see on our right side, so it starts synchronization process with the grid. Yeah, so we are now on the grid, and we can see how actually active power is ramping up. Yeah. Also here we can see how actually how it's actually ramping up. Also, this is actually these two signals is actually coming from controller, so it's actually regulate the speed and regulate the voltage. Okay. So now we can play around with controller, change some power, ramping up, ramping down, and so on. Also, there is possibility to use some communication protocols such as Modbus. So we can also use some third party, let's say microgrid controller, where we actually can send some power reference to it. Okay. So also there is a possibility, as you can see, I can easily stop this engine just using the button stop, and it will actually ramp down the power, and then it will turn off the generator. So in this case, you can also see how actually the power from other generator is from the second one is ramping up because there is lack of power in the system. Okay. So as you can see here, also it's stopped, and more or less that's it with simple example how we can actually connect the real controller to our system. Okay, so the next thing that I'm going to show you is actually our cell protective relay. So I hope you can see it right now. Also, I'm going to jump back to our route, and then here we can actually follow the signals from in this case from relay, protective relay, actually from that thruster that we are having. So there is also possibility using some buttons that we can, for example, load ramp up or load ramp down. So let's ramp it up. So this is, you can see how it's actually jumping the value, and now we're going to create some fault. And what is good about this capture and scope, that we can actually capture that moment when that fault occurs. So we can see perfectly nice what is actually happening in that situation. In this case, we have here some trigger that we set on the fault, and let's try to catch that fault and see how current actually behaves. Okay, so now I set the trigger, and I will now do the fault. Okay, yeah. So as you can see, our relay actually react, and now you can see that it reacts on overcurrent. And here, let me just show you a little bit briefly. And here you can find actually the moment when we introduce the fault to our system, what actually happens. So you can see the rise of the currents, and then you can see here also the moment when it actually contactor is open. Okay, so it's a pretty nice showcase. Okay, so also we can reset the relay, then going back. Okay, so the next thing that I'm going to show you is actually our It's actually our AccuSine Schneider Electric active filter. So as you know, in our system, we have some rectifiers, and as you know, it will generate some additional harmonics to voltage and current also. So how we can actually fix that? We can use some compensators, or we can introduce element from power electronics, which is actually active filter. So in this case, I'm going to show you what we have here. So we have some measurement of current, and I'm going to show you now how it actually will look like when we start the active filter. Okay, so I hope you can see here now our screen. So let me try to start our system. Yes, and here you can see how it actually, this is on the second window, you can see the currents from thruster, and this is actually compensated currents that actually grid sees it. So you can see how it actually fixed this problem. Okay, so I can stop the system once again. Yeah, and you can see the difference. So also there is possibility, let me start again, and we can enable and disable some additional harmonics. So as you can see, all of them is actually activated. I hope you can see it well. So it's actually a list of all harmonics. So we can disable, let's say, third. Oh, let me just insert the password. So let's disable third. Let's disable fifth. So here you can see how it actually changed the output current. So let's try to enable them. Actually, yeah. You can see the behavior of our active filter. So this is all the off-the-shelf components that we are managed to integrate in our system. Okay. Also, I can jump on the battery inverter. So it is EPC controller, and it's actually there is nothing to see here much. So you can see that we actually use this is actually our inputs and outputs pins, and we use these cables to connect it with the card with the controller actually. And in this case, as you can see, you can provide some communication protocols. In this case, we use CAN. And I'm going to now run one of these inverters just to show you how it behaves. Okay. So EPC. Okay, so for this demonstration, I'm going to run the software from EPC. So I think we won't need camera anymore. So I'm going to disable it. Okay. So here, as you can see, it's actually company's product from EPC. As I said, so let me try to run this inverter. So it's actually pretty easy. I'm just going to enable the. And now here on our right side, we can see how it actually behaves. This is actually the currents from the inverter after the filter, and this is the currents before the filter. So this is just output from the inverter. So, for example, I can increase the active power here, 50 kilowatts. Yeah. And also here we can follow the state of charge of the battery. So we are now pushing the energy from the battery to the system, and we can see that it's actually decreasing. And also you can see here how it actually affects on the system. So also we can find some capture here. So let me decrease the time interval. So as you can see, this is the currents. This is the currents, and this is the voltage, and this is the currents with the ripple. So you actually can follow the ripple here of the inverter. Okay.